Well, hello everybody. What I need to do today with you is I need to cover Section R.5. But if you're watching this video, that means that you did miss our quiz, R-1 through R-3. So make sure you get in and get that caught up. What I need to do whenever we solve an inequality, you hear the word inequality, guys, that means we're dealing with statements that have a greater than or equal to, a less than, or less than or equal to sign in there. A lot of what we'll do today is review when it's linear. When it's not linear, meaning quadratic or cubic, I need to show you a method called, I call it the number line game, the critical point method. So that part will be brand new to you today. So jump over to your class notes. I'm going to mention a few things. I put this slide in there just to, every year it seems like I get somebody says, now wait, what's the greater than sign look like? Remember, the greater than sign looks like that. The less than sign points to the lesser numbers on the number line. So, and then if we include those numbers, remember we underline it so we get the or equal to. So I'll review some things with you as we go. Now, when we're dealing with inequalities, you have the power to do the following. You can add any number as long as you do it to both sides, and it does not change the truth of the inequality. You can multiply both sides by any positive number, and if you do, it does not change the truth of the inequality. So meaning 5 is greater than 4. Well, if I'm going to multiply both sides by 6, well, if I do that, I got 30 is greater than 24. I still get a true statement. The only rule that we have to work with those in inequalities is when you multiply by a negative number. When you multiply by a negative number, we have to flip the sign. So once again, if I had 5 is greater than 4, if I want to multiply both sides by negative 3, I'd have negative 15 is greater than negative 12. Notice that that's a false statement. For me to make it a true statement, I need to get rid of that greater than in this case and change it to a less. So that's just the little rules for inequalities. Today, especially since you have the TI-84 calculators, we want to leave our answers, our solutions, as rational numbers. Rational being a nice fraction. So you get an ugly decimal on your calculator, go math, enter, enter, and then we got it. Now, if you would, come over to your number 1. I'll review solving these with you real fast. I'll review what the graph looks like, and then we'll go from there. On my number 1, since this is linear, there's no squared or anything, we can't factor it. And I think I'm going to write in white. I've got negative 5x. I'm going to add 4 to both sides and get 20. I'm going to divide both sides by negative 5. And once I do that, I need to flip that sign. So I got x is less than negative 4. Now, on a number line, I'm going to show you 2 ways it could look. Here's negative 4. That means there's negative 3 and negative 5. Traditionally, what we do is, since this is just less than, we would have an open dot on the negative 4, and we would shade everything to the left. So open dot. Now, you can also see it, instead of an open dot, you could see it as a parenthesis. Remember, in interval notation, the parenthesis does not include. Sometimes in higher level mathematics, they just draw it like this, because it makes the notation, the interval notation, be this, negative infinity to negative 4 in parentheses. Graphically, guys, I really don't care what we do. You've been taught to use an open dot, so I'm fine using an open dot when we graph them. If it includes them, we'll use a closed dot. Now, number 2, you were taught this last year in Advanced Algebra 2, but you were taught to read this as an AND statement. What I would like to do this year, though, is I would like to solve 2 equations at the same time. It's just quicker. So I've got negative 5 is less than 3x plus 4, which is less than 15. I'm going to try to get x in the middle all by itself. So I'm going to subtract 4 from all 3 sides. So I've got negative 9 is less than 3x, which is less than 11. Then I'm going to divide everything through by 3. So I've got negative 3 is less than x, which is less than 11/3. Now, guys, make sure you can read this from the variable. This says that x is greater than, because it opens up, x is greater than negative 3, but x is less than 11/3. On our number line, it would look like this. I've got negative 3, I've got 11/3. It doesn't say or equal to, so we would have two open dots. That's one way it could look. The other way it could look, these could be parentheses. Okay. In interval notation, though, negative 3 comma 11/3. Okay. Number 3, I tossed on there just to make sure you know how to read from the variable. So once again, I would like to get x in the middle. So I'm going to multiply through by 3. So I've got negative 21 is less than negative 4x minus 6, which is less than 54. I'm going to add 6 to everything. So I've got negative 15. Let me start again. This would be negative 63, wouldn't it? Now, let me add 6 to both sides and get negative 57 is less than negative 4x, which is less than 60. Let's divide everything through by negative 4. Well, if I do that, I've got 14.25. Now, since I'm dividing by negative, I need to flip that sign, so I got greater than x, which is greater than negative 15. Now, this is written improperly. Your biggest number cannot be there. The biggest number needs to be there. So I'm going to rewrite this, and when I do that, it's going to look like this. It's going to say 15. Notice it says x is greater than 15, so negative 15 is less than x, but x is less than 14.25. When we list this, we need this to be our littlest number, this to be our biggest number. Now, once again, when I graph this, I've got negative 15. I've got 14.25. We've got either open dots or parentheses and everything in between. So I want to throw that one in there just to make sure you could read from the variable. Now, my number 4, just like when we solved fractional equations, we're going to do the same steps when we're solving them using inequalities. I'm going to multiply through by some magical number that's going to get rid of the fractions. So I'm going to multiply through by the least common denominator, which is a 10. If I multiply through by a 10, 2 goes into 10 5 times x, so I've got 5x plus 2x is greater than or equal to 60. I've got 7x is greater than or equal to 60. I'm going to divide both sides by 7, and guys, I don't even touch my calculator. I'm going to call this 60 over 7. 7 is a prime number, so I know that does not reduce. My graph would look like this. I'd have 60/7. Since it's or equal to, it's either a closed dot or it's a bracket. And I'm going to the right. So that makes my interval notation bracket 60/7 to infinity. So guys, I've kind of clicked through some linear examples there. I'll slow down just a little bit with our quadratics. So here's your number 5. I've got x squared minus 2x minus 8 equals 0. I'm going to show you how to do this via what I call the critical point method. Critical points are really our x-intercepts, our solutions. But since it's a squared and we can factor it, that's what we're going to do. So I'm going to factor x squared minus 2x minus 8, and I'm going to get x minus 4, and x plus 2 is greater than or equal to 0. Now, here's where the critical points come in at. My critical points are the numbers that I get when I set each of those parentheses equal to 0. So one of my critical points is x equal 4. My other critical point is x equal negative 2. Now, here's where it's going to be new to you. I'm going to put 4 and negative 2 on a number line. I know right now, since it's or equal to, these are brackets or closed dots. Now, this will be brand new to you. Here's how you handle what we call the critical point method. You pick a number within an interval. So, for instance, this right here represents all the numbers greater than 4. You pick some number greater than 4. I don't care what that number is. So we're going to pick on 5. Now, I don't care what the answer is. I only care if it's positive or negative. Here goes my thinking. If I get a positive number, I know that's greater than or equal to 0. If I get a negative number, I know that's less than or equal to 0. So it's going to look like this. I'm going to pick a number greater than 4. I'm going to plug that number back up into my parentheses. Now, I will not say numbers. I will say positive or negative. So 5 minus 4 is some positive number. 5 plus 2 is some positive number. A positive times a positive is a positive. Now, guys, let me explain to you what we just found. If you plug in any number greater than 4 into x squared minus 2x minus 8, you are going to get a positive number. And this positive number will be greater than 0. Now I'm going to do the same thing for any number between negative 2 and 4. Well, anytime 0 shows up, that's what I like to use. So 0 minus 4 is negative. 0 plus 2 is positive. A positive times a negative is a negative. So once again, the explanation, if you pick any number between negative 2 and 4 and plug it into x squared minus 2x minus 8, which is equivalent to x minus 4 and x plus 2, you will get a negative number. And I'll show you which ones we pick here in a second. Now I'm going to pick a number less than negative 2, so I'm going to pick negative 3. Negative 3 minus 4 is negative. Negative 3 plus 2 is also negative. A negative times a negative is a positive. Now, come back up to your original statement and look at what you need. I need x squared minus 2x minus 8 to be greater than 0. That's a fancy way to say I need wherever it's positive. Well, look at your number line and see where it's positive at. It's positive from 4 to infinity and negative infinity to negative 3. So it's going to look like this. My solution is negative infinity to negative 2. We're going to include negative 2, but not include infinity. And then I put a U. Be careful, Math Excel sometimes has you put a comma. And then I'm going to put a bracket 4 to infinity. So guys, I chose the positive intervals because of right there. It said greater than 0, so I needed the positive intervals of it. Now, also, I want to mention this real fast. I wouldn't mind switching colors if it'll let me. Think about the graph of x squared minus 2x minus 8. It's going to be a parabola opening up. Well, that parabola would look like this. It would cross the x-axis at negative 2 and 4. Notice this. This branch is above the x-axis, meaning positive. This branch is above the x-axis, meaning positive. This area is below, meaning the negatives. So you can also think about the graph. But I got to get you good with playing the number line game. So here goes your number 6. I will just pick the pace up a little bit. So on my number 6, we're going to think of this as x squared minus 5x minus 14 is less than 0. That way, because it's a quadratic, we're going to factor it and get x minus 7 and x plus 2 is less than 0. That makes my critical points x equals 7 and x equal negative 2. When I put them on my number line, I got 7 and negative 2. Since it's just less than, I know later on these are open dots or parentheses. We'll take care of that here in a minute. Now, you pick some number greater than 7. So I'm going to pick 8. Once again, guys, we don't care about the number, we just care about the sign. 8 minus 7 is positive. 8 plus 2 is positive. A positive times a positive is a positive. Now, if you think about it, we don't want this area because less than 0 means negative. I'm going to pick a number between negative 2 and 7. I'm going to pick 0. 0 minus 7 is negative. 0 plus 2 is positive. Any negative number times a positive number is going to give me a negative number. Pick on a number less than negative 2, such as negative 3. Negative 3 minus 7 is negative. Negative 3 plus 2 is also negative. So what does this tell you? Any number in the whole wide world that you would pick less than negative 2 is going to give you a positive number. Now, we just decide if we want it or not. Since it says less than 0, we're going to go find the negative areas. Well, the negative area was that right there in the middle. So my solution is negative 2 to 7, and I use parentheses because it just said less than. It did not say less than or equal to. Now, your number 7, since I'm blocking part of it, it looks like I've got 3x squared. I'm going to move that 7x over. So I've got minus 7x minus 6 is greater than or equal to 0. So once again, something I know, we need the positive areas. This is one of those frowny face factoring ones. 3 times negative 6 is negative 18. Two numbers that multiply to be negative 18. Looks like negative 9 and 2. I'm going to go 3x minus 9. 3x plus 2. And I need to divide by 3. So factored is x minus 3 and 3x plus 2 greater than or equal to 0. So let's go grab your critical points. My critical points, my critical numbers, is going to be x equal 3 and x equal negative 2/3. So 3 goes there, negative 2/3 goes there. Here comes our number line game, as I like to call it. So I'm going to pick a number greater than 3, so I'm going to pick 4. Remember, you're going back to your parentheses every time. 4 minus 3 is positive. 3 times 4 plus 2 is also positive. This positive number times this positive number will give me any positive number. We're kind of getting lucky on the 0 thing. 0 is between negative 2/3 and 3, so I'm going to pick 0. 0 minus 3 is negative. 3 times 0 plus 2 is positive. So this area is negative. And then I might pick negative 1. Negative 1 minus 3 is negative. 3 times negative 1 plus 2 is also negative. So I got positive. Now, don't always assume that it goes positive, positive, or negative, positive, negative. For today, most of them do, but not all of them. Now, come back up here. We want the intervals greater than 0. So that's this interval and this interval. It says or equal to, so it looks like I'm going to have negative infinity to negative 2/3. I need to include the negative 2/3. Of course, we never include infinity. Union, along with 3 to infinity. So there's my number 7. Now, I'm going to skip my number 8 just for time on the video, but I'll do number 9 because I've kind of spoiled you where it went positive, negative, positive, positive, negative, positive. I'll show you that's not always the case on number 9. So like I said, I'm going to skip number 8 for the video. If you want to pause the video and do it, you should get negative 3/2 to 5/3 after you're all said and done. But now number 9, I've got 9x minus 3x squared is greater than or equal to 0. So we're looking for the positive intervals again. Well, the golden rule of factoring says take out whatever they have in common. So I'm going to take out a 3x, which leaves a 3 minus x is greater than or equal to 0. Makes my critical numbers x equals 0 and x equal 3. We'll put those on the number line. Pick some number greater than 3. So I might pick 4. 3 times 4 is positive. 3 minus 4 is negative. So that interval is negative. Any number greater than 3 is going to give you a negative number. I can't use 0 this time. A number between 0 and 3, though, is 1. 3 times 1 is positive. 3 minus 1 is positive. A positive times a positive is a positive. Let's pick on negative 1. 3 times negative 1 is negative. 3 minus negative 1 is 4, which is positive. So I got a, oh, that's a positive right there. Is a positive. Now, look back at what we want. We want the interval greater than 0. And it says greater than or equal to. So my solution set is bracket 0 to 3. So there's where we are so far. Now I'm going to slip number 10 in there because you can kind of just see the numbers, and I just wanted once again reinforce the positive or the negative. As soon as I see greater than 0, we want the positive. Now your critical numbers. Looks like they're going to be x equal negative 3, x equal 2, and x equal negative 7. Let's put these on the number line. The biggest number is 2. The middle number is negative 3. My smallest number is negative 7. Pick a number within each interval. So any number greater than 2. So I might use 3. 3 plus 3 is positive. 3 minus 2 is positive. 3 plus 7 is positive. A positive times a positive times a positive is a positive. So this is one area that we want here in a minute. Don't assume negative, positive, negative. It is in this case, but not always, I promise you. A number between negative 3 and 2 is 0. 0 plus 3 is positive. 0 minus 2 is negative. 0 plus 7 is positive. I got one negative, so it makes that interval negative. Let's pick on negative 4. Negative 4 plus 3 is negative 1. Negative 4 minus 2 is negative 6. Negative 4 plus 7 is positive. So that makes this interval positive. And then let's pick on negative 100. Negative 100 plus 3 is negative. Negative 100 minus 2 is negative. Negative 100 plus 7 is negative. And 3 negatives make a negative. And then guys, we want the positive intervals, and it says or equal to. So I need to go negative 7 to negative 3. Union along with the other positive interval was 2 to infinity parenthesis. Okay, so guys, that's most of the lesson. I got to show you how we're going to handle fractions now. So here comes my number 11. Notice that there's a fraction. Remember, whenever we add or subtract fractions, we are going to get a common denominator. So it's going to look like this. I'm going to call this 2y plus 3 over y minus 5 minus 1 is less than or equal to 0. Now, one thing I know, guys, as soon as I saw less than or equal to 0, we want the negative intervals. Now, my common denominator is going to be y minus 5, because the 1 just has a 1. So when I go from here to here, I don't need anything. So I've got 2y plus 3. But now, when I go from here to here, I need to multiply by y minus 5. So to the negative 1, I'm going to multiply by y minus 5. And that's going to be less than or equal to 0. Let me simplify the numerator. So I'm going to have 2y plus 3 minus y plus 5, which is going to be y plus 8. So I've got y plus 8 over y minus 5. Now, to get your critical points here, it's whenever the numerator equals 0, which makes the fraction 0, or the denominator is undefined. So in this case, my critical points are going to be at y equal negative 8 and y equal 5. Guys, don't let the variable mess you up. X, Y, Z, A, B, C, that part doesn't matter. The process is the same. There's a 5 and a negative 8. So, the same steps, but yet there's a fraction. So, I'm going to pick a number greater than 5, so I might pick 6. 6 plus 8 is positive. 6 minus 5 is positive. A positive divided by a positive is a positive. So we want that interval. Let me rephrase that. Up here we just said we wanted the negative. Whoop, come back. Let me rephrase that. Just a second ago we said we wanted the negative intervals. So I don't want this interval. Now let's go pick on between negative 8 and 5. I might use 0 again. 0 plus 8 is positive. 0 minus 5 is negative. So this interval is negative. Number less than negative 8, I might use negative 10. Negative 10 plus 8 is negative. Negative 10 minus 5 is another negative. Two negatives divided by each other is a positive. And then we said we wanted the negative interval. So be careful here. Our sign says greater than or equal to. So we want to think close dot, which means bracket, bracket. But if you look at this, you are not allowed to use positive 5. So my positive 5 really becomes a parenthesis or an open dot. So here's your solution. I'm going to erase this little bit of area here. Your solution becomes a bracket on 8, and on bracket on negative 8, and on 5 a parenthesis. The reason for the parenthesis, you can't use the 5. Okay. I'll hit number 12 with you. It's got a little bit more work in there. So once again, it's a fraction, so I'm going to think of this as, so let's rewrite this as 8 over p squared plus 2p minus 1 is greater than 0. Let's go get our common denominator. I'm going to think of the p squared plus 2p as p times p plus 2. So from here to here, I don't need anything. So the 8 gets left alone. But the negative 1 gets multiplied by p times p plus 2, which is the same thing as p squared plus 2p. So we're going to have minus p squared minus 2p is greater than 0. So now we got a little bit of work to do. I'm going to think of the top as negative p squared minus 2p plus 8 over p times p plus 2. I don't like the negative p squared, so I'm going to take out a negative 1, which leaves me p squared plus 2p minus 4 over p times p plus 2. I'm going to factor the numerator into p plus 4 and p minus 2 over p times p plus 2. Now, this one's going to work us a little bit. My critical numbers are going to be p equal negative 4, p equal positive 2, p equals 0, and p equal negative 2. So I got 4 numbers to worry about in this case. So when I put them on my number line, see if I can switch colors here for you to see, I'm going to have a negative 4, I'm going to have a negative 2, I'm going to have a 2, and I'm going to have a, I need negative 4, I need negative 2, I need 0 and 2. And then we got to just play the number line game down on here. So I'm going to pick 3. So I've got negative 1. I need to keep that. 3 plus 4 is positive. 3 minus 2 is positive. Over a positive times a positive. Well, this negative 1, that negative 1 makes that interval negative. And then just to speed up the process of the video, it does go in this case, that's a positive, that's a negative, that's a positive, and that's a negative. And we would need the positive intervals in this case. So, looks like my solution would be negative 4 to negative 2, along with 0 to 2. But the key thing on the fractions, get a common denominator first. So guys, there is section, it's a tough little section, there is section R-5. Good luck.